And one for honors students. This is your honors homework day 11 answers. Just to make sure you understand what's going on. Student number 1. You're driving on the street and there's a panda. Ugh. You skid 673 meters. So right here you've gone 673 meters in 0.303 minutes. Convert it, you get 18.18 seconds. You end at rest, so the velocity is also 0, and that's the end part of your trip. What was your initial velocity? Well, in your table you have time, displacement, final velocity, trying to find initial velocity. That looks like it's going to be this. Put in your math, and you'll end up in the beginning finding your velocity to be what, 74.03? Which is pretty dang fast. Then letter B says calculate your acceleration. By adding acceleration on, I can pick any equation that's got any of these 4 in there, but I want A. I'm going to use this. And to get your result. Not too bad at setting up. Almost all of you got that. Instead, what's going to happen now is I want to talk about the second one. In the second one, you have this velocity, well, this acceleration. It says, does that mean you're getting faster? And the answer is, of course, no. The reason is, let's say it's positive. If you're going forward, this means you're getting faster because you're gaining that much forward speed. So if you're going 1 meter per second, the next second you're now going 1.004 meters per second. The problem is if you're going backwards. Let's say you're going backwards at -1 meter per second. If you have this positive acceleration, the next moment you're going backward at -0.996 meters per second. You're now going slower. The end result is that a positive acceleration increases your positive velocity, but it will decrease your backwards or negative velocity. It's like a negative acceleration will increase your negative velocity, but it will decrease your forward velocity. And now let's try part 3. Off. And ready for number 3. In number 3, we've got all kinds of stuff happening. We have a panda starting with a velocity of 2. We have a panda ending with a velocity of 1. It takes 2 seconds. 3 seconds? Takes 3 seconds. And part A, I'm sorry, the first part it says find your acceleration. Almost all of you got -1/3 for that. That's quite easy because you know VI is 2, VF is 1, time is 3. You can easily find A. That's what I want to focus on. I want to focus on letter A, the displacement, first. Finding displacement from this is not too bad either. I would do D equals 1/2 VF plus VI times time, and I'm going to get 4.5 meters. What really screwed up a lot of people is letter C. And that was, how far did it go for the first 2 seconds? So look right here. I'm now going to look at 2 seconds in. Is the velocity at this point 1? No, because that's afterward. Is the displacement still 4.5? No. Is the acceleration still -1/3? Yes. So for this information, we have a new set of information here. I'm looking at this part right here. The initial velocity is still 2. The time is 2 seconds now. The acceleration is -1/3. And we're going to find the displacement. So looking back up here, all I've done is just put a new point, circled it, and this is my start and end. Anything outside that is unknown. Do my cute little equation, because I will. D equals VIT plus 1/2 AT squared. Plug it in and you get D is going to equal 2 times 2, which is 4, plus -0.666. which is
Devil's number.
3.33. It is the devil's number, but not in physics. The numbers are just numbers. Nice. We just found it. And then if you don't mind, let us go to number 4 over here. In number 4, you've got my first car ever, 2003 Pontiac Grand Am, because I'm cool like that. 2004 Pontiac Grand Am. Apparently I don't know my own life. The initial velocity here is 45 meters per second. That's VI. And then at some time, the velocity is going to be going to 0 because it ends at rest. The acceleration is -5 meters per second squared. If we're trying to find out how far it can go, when something reaches as farthest it can possibly go, the velocity is 0. Let me go note to myself. For max distance, velocity is 0, final. I'm going to use this relationship, VF squared equals VI squared plus 2AD. I know I can't see that well, but I already chose it. And by solving it, I will get displacement. VF is 0 squared equals 45 squared plus 2 -5D. 0 squared is 0. 45 squared, I can't remember that right now, but 2025. Plus -10D, move it over. -2025 equals -10D. Divide both sides by 10, negative, you get 202.5 meters. Then it says, what if the initial velocity was actually 90? Do the math again, but put 90 in. It still has the same acceleration. It still ends at 0. And you'll get, if you double the displacement, it is 4 times the distance, or 810 meters. With that, my wonderful friends, we are done. Have yourself a great day.